Hello everyone, welcome to today's Novedge webinar, Onshape CAD and Collaboration for Rhino Users. Take on more advanced projects by adding Onshape to your Rhino environment. In this session, you will see the day in the life of a cross-functional design team. We will take data from Rhino, add it to the Onshape environment for DFM features designed for manufacturability, and perform a real-time design review with the customer and manufacturer. So this is not something you don't see every day. Today's webinar or presenter, sorry, we have the wrong. So today's webinar presenter, Mike LaFleche, also known as the professor, is a fixture in the 3D CAD community. Mike previously worked for multiple SOLIDWORKS Value Added Resellers in training and sales, and he has also worked for companies in the real world in mechanical and electrical design positions, utilizing a myriad of CAD systems. He is the man. And let me tell you a little bit about Novedge and where you can find Onshape. This is our product page, and Novedge is changing the way designers purchase 3D software, offering more choices, more freedom, best advice, and faster service. Check us out at novedge.com. Now I'm going to share Michael's screen. Take it away, Michael. We're all very excited.
There we are. You can see the slides now, right?
Yep.
Perfect. Thanks for that great introduction. I was blushing the whole time. I'm really excited to show you Onshape, which is a true software as a service design application. And it's something that people use in a variety of ways. But I want to kind of talk about our friends who are Rhino users. And it's a very complementary piece of software in the design space. Quite often people begin, their design projects in Rhino, and then they pass through the design chain and supply chain to other stakeholders. And people typically receive Rhino data and import it into other mechanical CAD systems for the design for manufacturability, for manufacturing itself, getting the right features, in the product, and then doing all the rest of the documentation and revision control so that your product is properly documented, right? So let's hop right into this. So we'll talk about the right tools for the job, right? So, you can use Onshape to design all of these shapes that you see here today. In fact, I have in the past, but you can import data from a variety of sources that might already be done or from another design consultant using Rhino, right? So Rhino, very well-known software, very popular in the industrial design, kind of conceptual design space. But that's kind of where it ends, right? With Rhino, it's great at doing its job. And, when you start to share and collaborate your Rhino design data with other stakeholders, there's a variety of things that will occur, that kind of make life a little bit difficult to work with these files flying back and forth. So I'll talk about that on a couple of slides. Then we'll dive in and do a live demo of Onshape. We'll work with Onshape native data. We'll import images. We'll import Rhino data. Of course, we can export Rhino data. It's going to be fairly informal. I just kind of want to walk through how a typical design phase goes with Rhino and with Onshape. And then I'll show you some other ways companies are innovating with the new workflows that that this provides, right? So hopefully it'll open some eyes, and get the gears turning, in that brain of yours. So let's go back about 30, 40 years, right? So I've been in the CAD world for 30 years or so, and you can see it's taken a toll on my hairline, but it's okay. I'm going with it. I'm not fighting with it. So, but anyway, the design world hasn't really changed that much from the old paper and drafting board days, right? If you think about it, you're taking well, let's just kind of go back 30 years, right? You take your CAD drawing, or not CAD drawing, but paper drawing, your vellum drawing, right, out of the drawer. You bring it onto your drafting table, you do your work, you make your design changes, and you put it back in the drawer. And you might take a copy of it with a blueprint machine, so you have a backup copy, of this. So, it depends on, how detailed and fastidious you are, in your data management. But this is a very common, kind of thing that you would see 30, 40, 100 years ago even, right? We were designing aircraft carriers this way, right, back in World War II. So in the other, if you think about what we've done in the digital transformation world, going from hard copy drawings with pencil and paper to the digital world, all we did was really duplicate that old school process, right? Let's say you start a design here with your MacBook computer and you're running Rhino, and you're creating 3DM files, right? And you're doing your work, you're working on your local hard drive, you're storing your files on a server, and then you're going to share that with somebody else. Now, it could be internal to your company, or it could be external to your company, right? Most of the time it's external, right? I know a lot of Rhino users that are in the design consultancy space, doing consumer product development and design. And then they'll work, for essentially a original, OEM equipment manufacturer, doing a medical device or some kind of consumer product, and they've contracted with you to do that design. Now, the OEM manufacturer wants those Rhino files in a variety of different formats. You're probably going to export them as a step or an IGES. Some systems will let you import a Rhino file. But then it will be converted to another file type. It'll be converted to the CAD, mechanical CAD format, whether it be Creo or Inventor, or SolidWorks, all the common ones that are out there, right? So, you do your design changes here in the mechanical system for design for manufacturability. You're going to add fillet radii, draft angles, designing it for the manufacturing process at hand, right? Going from conceptual design to true design for manufacturability. And then you create all your detailed drawings, and then you probably put it under revision control. A lot of companies will have what they call PDM systems, right, for managing that revision automatically. Instead of file management, it's a database of files that are being managed by a system that you deploy and implement. So if you look at the screen, there's a lot of things that you have control over, right, with the servers. You have to manage the risk of keeping your own servers, keeping your own backups, dealing with all the file copies and revisions, and sometimes buying a PDM system to manage that on top of your already expensive CAD system. So that's a typical workflow. But what happens if you go from V1 on the 3DM Rhino file to V2, right? And the engineering teams have already started doing their design for manufacturability at the OEM manufacturer. That ends up being a pretty big problem, right? When that change happens. So, we thought that there could be some newer, better things that could be done in this day and age. Here we're in 2021, far removed from the old drafting board days that I started on myself. I quite enjoyed it. It was quite artistic. But when you're working in like that timeline view, you see which way the arrows are pointing over here? They're all going in one direction, right? You can become a salmon and swim upstream and try to do things, but for the most part, it's one person at a time doing work, sharing files like you have on a relay race where you pass the baton from one runner to the next. And that's the way file systems work today, just like paper drawings. So this leads to a serial workflow where only one person at a time can do work on any one given file. So let's say you have Ed the engineer, you have Mark in manufacturing, you have Debbie on the electrical side, or Emily. I'm trying to pick alliterative names just to try to remember them. But all these people are working on data, but they can only work on it one at a time in a silo. And you might say to yourself, well, of course, that's the way we work now. You know, it's the only way to work, right? But in the world of technology, there has been a major shift in how people can work. You know, let's just pretend we're outside of the design department and we're in marketing or sales or something like that, right? Let's put another hat on. All these different parts of the business are using software as a service technology to improve their workflows and how they can get the job done. So when you work inside of these tools, it's very easy to collaborate with one another. First of all, the software is hosted, software as a service typically, and you're able to work, you know, with your people very quickly and easily, instantly. Think of Google Docs, right? If you've ever used that, you know, that's another analogy that you could use to show how the rest of the industry is working toward a more collaborative process. And there's lots of other shadow collaboration, you know, that's out there, right? I mean, you might not think you collaborate today, but I bet you do. You send emails, you make phone calls, you write Post-it notes, you write letters, you know, whatever it might be. These are all forms of collaboration, you know, and of course with email being very asynchronous, right? And, you know, prone to file copies, you know, you have lots of file copies that can go out in an email. So this really leads to this metric that best-in-class companies track called cost of delay. Cost of delay means if Ed the engineer shares something to Mark the manufacturing engineer, if there is work that needs to happen back over here because a problem was identified by Mark in the manufacturing department, there's going to be a cost of delay. And if you look at it in the y-axis, that will cost money in US dollars or whatever currency that you're working in, or it's going to cost you time, right? But in the demonstration you'll see here today, we're going to be able to try to stack the work a little bit more because of the technology that we have that allows that to happen. So this also kind of benefits you as the designer or the consumer, because you're going to be shared into information much quicker if you were using a more up-to-date modern workflow. So let's get into a demonstration. You know, we'll leave some time at the end for questions, but we'll do a design review first, right? Before we decide to go ahead and make any kind of big design changes to this motorcycle helmet. So we'll do this design review, and you know, we'll have some Rhino data that's been provided to us to help with the design process. We can also take that Rhino data and work it into the full mechanical design inside of Onshape in this case. We'll collaborate with a contract manufacturer as well during this demonstration. And of course, we'll do all of our normal things that a mechanical designer would need to do. You know, that you might be a person on the call that does both, right? You're both the internal kind of conceptual designer using Rhino, but you might also be the person who's doing the documentation and release planning. You're making your own product, right? So this is also a very good workflow for you to kind of go through and see. And of course, finally, we'll release it to production with proper audit trails and you know, a listing of who did what and when, with approvals, right? You know, signatures on these drawings, if you will. So let's start with the live design review use case. So an interesting thing that I can do, like I'm going to click on this helmet, right? And when I click on that helmet, it's going to open Onshape. Now, of course, that's pretty interesting, right? Because I'm in a web browser. I was on Google Slides here on one page. I had a hyperlink on that image, and I went straight in to the timeline of this particular helmet. And you can see that I have the Onshape environment loaded up here. So when I say loaded up, there was nothing for me to install or load on my computer. Actually, if you look at this, you can see my picture there. You can see, the helmet, and you can see another window over here. And I'm running on a MacBook computer. So this is the pleasant thing, because Rhino, for example, runs on Windows and Mac. The Onshape environment runs on any platform because it runs in a web browser. You simply go to cad.onshape.com, or if you have an enterprise account, you're going to have your own unique domain like I have, and you're going to be able to just sign in and go and just work, right? So it's really, the first of its kind type of CAD system that just runs natively in a web browser on any device. Right? You can run this on your phone, on your MacBook, on your Windows PC, Linux machine, Raspberry Pi. I'm just kidding. You probably could actually, but any device that's modern with a web browser will suffice. And I've opened this design to an assembly tab, and you can see that in Onshape we have all the capabilities for doing your full-on design that you would need for the final product, right? Your bill of materials with material specifications, release states, exploded views. Here we have this visor here that we need to perform a cleaning operation on, and it shows us all the steps required. I'm going to remove this screw, right here, with this particular driver that's in our tool crib, right? So, all the things that you actually need to do to bring a product to market, including, your detailed drawing capabilities. Like you see here, here's a simple blueprint here showing the bill of materials revision. You see over here is the listing of revisions and versions, which I'll get into as we go through it. And then, of course, your actual design itself, right? So I'll just go into the actual feature list here. This is where we actually design things natively in Onshape. But of course, we're going to import some data today too from Rhino. But no, I actually designed this helmet completely in Onshape with the surfacing tools that are available, in the Onshape platform. So Onshape is a collaboration platform that includes CAD and the data management and collaboration tools. So it's an interesting animal. There really hasn't been anything built like it. All right, so I'll get comfortable here, roll up my sleeves. Let's dive in. So in Onshape, when you open something, you can open it to a named version in your product development process, or a workspace, which is where you actually do your work. And you can see that I've branched here with these versions. So I'm going to create a branch from this dev v4. I'm going to call this dev v4.1. Actually, I'm just going to dev v4 IoT features. So in the old world, right, what would you do if you needed to kind of go off and try out some kind of different idea on a design that you have worked on? Well, you make a file copy, of course. You go to File, Save As, and you have another file that you throw on your desktop, right? And when you do that, you lose all tracking and traceability. All those changes that you do on the copy can only go forward in that copy. We'll show how this is a little different in Onshape, where we created a version in the timeline here. I created a version 4 before the webinar began, and I'm working on a branch of that version so I can try out my different design ideas, right? So it's a really good way of preserving your design intent and data control. And what I'd like to do, if I go back to dev v4 just for a second, I have some comments here. So Onshape provides a version trail on the side, a comment browser. So let me just kind of zoom in here so you can read it. You can see that Debbie the designer, I've commented her into something. We need to add more material to the back of the helmet, like you see in this image. Now I can click on that face right here and show, the markup that I created inside of Onshape natively. So just to show you how you would do something like that, you can create comments on the versions or the open workspaces, right? So if I wanted to, I could add a comment right here and say, you know, at Mandy in the manufacturing department, we need these made of ABS. So we need a mold design. And I could assign that work to Mandy. And as soon as Mandy is shared into this, it will share her into that particular design. And when you do that, something really interesting happens. So I'm signing into another window on the right side of my screen, and I can, you know, sort this kind of task list here, and you can see what's waiting for Mandy in the task list, the thing that I just created. So everything is a named user type system in Onshape where you sign in with your username. So I've signed in as Mandy in manufacturing here, and on my other screen there I am, like the manager. And I can see the helmet design, I can view that comment, and Mandy is shared into this design. She's provided the comment in the comment list, and she will then be brought right in, you know, to the view if she clicks on the little label on here. And if she selects the actual label again, it'll touch the face that was highlighted, right? But we can do markups and all sorts of other things, you know, in the comment list. And you can filter this on just my open tasks, or if you want to see completed tasks, right? So it's a very, very nice project management tool built right in to the CAD and data management system. So very nice to see that. You know, we're looking at that version, and I could go in and do the work on here, right? So I'm not going to do that. Actually, I am going to go into this branch, and I'm going to go on to that same branch as Mike the manager. So this is already completely violating the laws of known CAD physics right now, right? What I just did, first of all, I shared the design with Mandy in an instant. We did not need to package up, zip up a whole bunch of files, you know, find some way of securely sharing them with Mandy, who works at another contract manufacturing company. All I had to do was just share that information. Then I can actually double click on my collaborators, right? So if I was Mandy, if I double click on Mike's photo, now we're in the follow mode, where anything that Mike does from his point of view, you know, will actually show up on the other screen, including, you know, things that are hidden. So if I, you know, hide this part, you know, so we can see the visor and the grommet here, we'd be able to see that very easily. And of course, I can just bring it back, right? So excellent design review capabilities, which is something that always happens in that early design process where you're doing your design concept for a customer, or you're trying to share some information with a manufacturing partner to explain what's going on. And look what the manufacturing partner can do. They can select things and get measurements. So there's the area of that face. Maybe I want to measure the distance from here to here. I can see that distance showing up right here, 6 inches minimum distance. We can look at the, you know, the weight of all the parts right here. So it's going to generate a report. Even while it's generating that report, I can look at the comment list for that branch. There aren't any comments in this branch yet. So, you know, because it's software as a service, it's built in a structured way where, you know, you can actually do multiple things at once. It doesn't freeze your computer up. But anyway, we have this concept here, and right now Mandy is only provided view-only access, where Mike is in the full-on editing mode. But what I could do is upgrade the permissions for that other person. Is if they have an Onshape account, you know, they can edit. You know, we do have the ability to have viewers, you know, in the system, but this would require, you know, a full-on professional Onshape subscription to make edits, of course, right? So, but I'll update Mandy in manufacturing so she can edit. So if she refreshed her window, we will both be able to go in and provide some features. So let me just turn off this, make my windows a little bit bigger. And I'm going to reply to the comment. Actually, I'm not going to reply to the comment just yet. I'll do it when I'm done. So what you see here is a feature list on the side here where you can store various bits of information, about design. Like here was the original kind of photograph that I used as the basis for creating the helmet right here. So you can do that. And of course, you'd sketch out parametric relationships, to build up this. So this is a system, parametric feature-based design system, like all the major MCAD tools that are out there. But the nice thing about Onshape is that you don't have to worry about files, right? You can see that I can design multiple parts with one feature tree. So it's much easier to pick up than some of the other mechanical design systems out there. It makes it easy to design these together, because that's how you design. Like this visor needs to go and work with the helmet, of course, right? So that totally makes sense. So let's go in and do the next thing. We want to bring in a Rhino file that will help, with a design proposal that I want to work with. I want to create an indentation inside of here. I need to pop up this surface a little bit by 1/4 of an inch to fit a small circuit board, flexible circuit board in here for an IoT kind of sensor in the helmet that will detect, concussive events and send an alert to my iPhone or something. I'm just making this stuff as I go along. I don't think that's a patented object yet or not. I'm not sure. I haven't looked at it, but I am just going to do a quick design. So I already have a surface model that I got from a design consultant. Actually, let's have the design consultant do this, right? So I'll sign in as Mike over here, and I'm going to import, a 3DM file from Rhino directly, okay? So Rhino, obviously, very good surface design software, and many people prefer its kind of workflow, which is not a parametric workflow. It's more of a, you're kind of doing it in a more flowing fashion, your design work, right? You're creating curves, you're quilting surfaces over those curves. Or in Onshape, most mechanical systems are similar. It's very technical surfacing. It kind of takes the, I don't know what the best word of it is, but it's very technical, right? It's not free-flowing, push-pull type stuff typically. So I bring in that Rhino file, and of course Onshape can create these surfaces natively, which I've done, but I'm going to import the Rhino file, and that's what just happened. It brought it in, and I have this new kind of shape that I want to use on the top of the helmet. So it imported that Rhino file. If I look at my file list here, I have the assembly, the drawing, part studio where I'm doing my design work, and then the Rhino surface. Maybe just rename this so I don't need the extra suffix there. Here are my reference images. We can bring in anything into Onshape. It does not have to be CAD data. It could be photos, sketches, movies, whatever it might be. Here are some renderings that I created in our rendering app that runs in Onshape. The carbon fiber version of this. And then here are the actual CAD imports, right? Here's a human head, parasolid file. Here's a movie. And here's the Rhino file, right? So it keeps track of all the imported data. And that's all kept track of automatically in the version history. You can see I imported the Rhino file into the Onshape database. So every single change is tracked. So let's go back to the design. I've imported that Rhino data, and it created a new tab inside of the document. And then I could just kind of bring in, I'll use this thing called a derive function. It's not important, the name of the function, but you can see I have that Rhino surface now that I can bring in and use in this design. And look what happened. It instantly updated Mandy, who still had the document open, right? So we were able to take that Rhino surface, and now I could use that Rhino surface to, extrude something or, split with it, cut with it, do various things with it. So instead of boring you, with a whole bunch of features, I already have some of these done on my main dev branch. So I'll bring them up to speed there. There we are. And you can see that I've done a little bit more design work, and I'll just kind of walk through, what I did. So, in Onshape, you have the ability to, let me go back a little more here. You can actually step through each of the tasks that you needed, right? So you can see here's that Rhino surface. Kind of a nice thing. Maybe I'll show you this, just so you can see what you can do with your Rhino surfaces when you're bringing them in to Onshape. Let me hide the helmet itself, and you can see that there's the surface model, right? And in Onshape, you can use any of the commands to work with either solids or surfaces, right? So if I wanted to make the surface bigger, we have this thing called move boundary. I could pick that face and then, extend it, by some amount, right? So that's one thing you can do with a surface, of course. And then you might use that to, split, this helmet up a little bit. I extended the surfaces up in Onshape of the original helmet, and I'm using the Rhino surface here that I've extended to, create a split, across my models. Then I can use it for a variety, of things. And we keep track of each surface here. Curves as well, right? So if you imported a Rhino file with curve data, that would also come in. But Onshape can create its own curves as well, right? And we use these for, creating advanced sweeps and things, 3D, other CAD systems call it 3D sketching. In Onshape, we have these purpose-built curve features that, like here's a 3D spline. And if I wanted to have a 3D spline that started, at this vertex point right here, and I wanted it to kind of flow along this edge, and I want the end of it, to be, maybe over here at, on this curve. Vertex, and let me just pick edges. Let's just do that. Oh yeah, here we are. We'll just first day with my new CAD system, sorry. Let's just use a bridging curve. I know I can use that one for sure. So I'll take that edge here, this edge right here, and it will create a curve in three-dimensional space to match up, right, to a particular place. If I hide the helmet itself, you can see what it's creating, right? It's creating a nice curve, and I have full control over the magnitude, of that curve. I'm pulling it in 3D space, and you can show the curvature plot on top of this, so you can see how these surfaces blend. You see how there's a little bit of a discontinuity here when I look at that? Well, that's because, I had tangency, not curvature control. So, you can set that right in these 3D curves, match curvature, and what that will do, let me just change the bias here. That's a little bit strong now. When I go to curvature control, something like that. And if I look at the curvature now, you show curvature on here and here. Now you can see that it's a nicer blend, when you're going from C1 to C2 continuity. But this is just, I'm just going off on a little aside here just to kind of show you that you have full 3D curve construction that's purpose-built for handling continuities, inside of the Onshape system. I just delete that feature from the list. So we've been doing our work, I just roll down to the end of this thing. And of course, let's just all go to the dev branch so we can all be up to date on the same concept design here. We've done our work here to create the the extra geometry on here, let me just show you one other thing. I'll actually perform this step live. So I have some surfaces right here that I've created from the Rhino surface. Right, so I can display just the surfaces. You know, here's the original Rhino surface. I did an offset inward. I had a couple of other helper surfaces that I used to, you know, create this geometry in here, right? So if I turned on the helmet, and by the way, you can, you know, set transparency and all that, just so you can kind of see through the objects a little bit better, or section views, whatever it might be. But now I have all the surfaces kind of in place, so I can remove that pocket that I need to fit in the flexible circuit board. So from that surface right here, I could do, you know, I could thicken it into a 3D solid. I could remove it from the helmet itself. I could provide the direct, you know, the offset thickness that it should have in here. And if I hit OK, what you'll end up seeing, if I hide the surfaces, is a nice cutout now matching, you know, that interior volume that surface created, right? So pretty cool to be able to get in there and see all that information, you know, directly from data that we imported from Rhino, created additional geometry in Onshape, and now we have this shape. And of course, you know, we would need to go in and add blends inside the system. You see how well Onshape creates a blend, you know, on that advanced geometry. And of course, you can see the curvature visualization in 3D as well, and Onshape on all of the surfaces. So here you'd be able to understand how light is reacting to the model. Really good. And guess what? Anybody who's view only, like if Mandy was just a viewer in the system, you know, you don't need to buy extra CAD licenses for people to view. The Onshape viewing system allows for all of this capability, the section views. You know, you can just drag through there just like that. And now Mandy can see the new cutout that Mike just created. And just think back here just for a second. How hard would it be to do what I just did? Like if I was using any CAD system, it doesn't matter which one, they're all the same. You're going to export a file, you might put it up on a Dropbox, and then somebody else needs to go in and reload the file. And there's a lot of back and forth. But in Onshape, everything is live, up to date, you know, because I'm looking at the live workspace. You can look at previous moments in time, but here it's just instant and automatic. You're able to keep up to date and have this kind of parallel design process. In fact, Mandy does have edit rights, so Mandy thinks that this fillet radius is probably not a good idea to be that big, because she knows that it's going to be hard to fill this with plastic the way it's set or whatever. I'm just, like I said, I'm making this up, but you know, maybe she wants to make it 1/10 of an inch instead of 2/10 of an inch. So she can actually make that change. In fact, it's probably not a good idea at that value. Let's go a little bit different here. You are seeing a live demo. So you can see here I've set that change, and of course Mike sees that change, and in the timeline view we're seeing fillet 24 edited by Mandy in manufacturing. You can see the change by Mandy, change by Mike, all here. And of course you could set the versions here. I'll call it dev v5. And it's not quite saving the model, everything's saved, but it's just putting a breadcrumb in time, so you have something to reference, right? You know, so it's easy to navigate this rich design history with this kind of timeline view. All right, so we've made our design changes. Maybe we want to send the data back in Rhino format for whatever reason. Now, what I could do is share with Mandy in manufacturing, and you know, I could give, you know, maybe I'll crank her back to view only So you can do that. You know, if the horse is never out of the barn, right? With Onshape, you can always just continuously track the information. So now she'll be view, but I'll give her a view and export. I'll also let her link, which means she could use this helmet in another design. So if she had a big motorcycle, she wanted to put a person on the motorcycle and put the helmet on in the CAD model, you know, we could do that. You know, just by doing this, but she cannot make edits anymore. She can't make copies of this, but I am providing export permission, even though it's view only. So if I were to refresh Mandy's browser, what you'll end up seeing happen is her CAD system becomes a viewer again, just like that. There's like a 15-second timeout. It would have done it automatically. I just wasn't patient enough. But now maybe we want to get this helmet or maybe another piece of this out in another file format. So Mandy, because she shared into the design and I gave her the export permission, I could choose the export permission right here and get it in a variety of other file types, right? So if I wanted to get it out in Rhino, you know, I could take it and download it to my local computer and open it in Rhino. You'll notice that, you know, I could, you know, invite other people to this because I've provided that permission. Maybe I want Emily to have access to this, and I can give her a password and expiration on this share. And, you know, it's going to actually go in and prepare an export to that person's email address. And if even if they don't have an Onshape account, it will give them an email, and it will allow that person to just receive it and download it at, you know, whatever the current state of it is, because I sent it from that dev workspace. If I wanted the person to only see version 5, however, you know, I could export that at version 5, essentially. So it will only give them version 5, even if I continue doing further work on it. So there's many reasons why you might want that. But very nice to be able to get it out in the format of your choice. Of course, STL for 3D printing and all that, you know, that's you know, table stakes, of course. All right. Other things that we end up needing to do to the design once it is complete is creating detailed drawings, dimensioned blueprints. You know, maybe we want to create an inspection print for the inlet here. So I'll just right click on it and I'll create a drawing of it. We'll put it on a 4-view piece of paper, 11 by 17 B size in inch. So that's one of my custom formats that I've set up. And now we have a nice piece of paper. And we have the 4 views automatically created. And then, of course, I could go in and throw in some inspection dimensions on here, right? So we can pick up on all that information, add tolerances. I'm not going to do a big, long drawings demonstration, but, you know, that's the, you know, pretty much the process that you would expect to see, you know, section views through various portions of the design are sometimes handy for thin-walled parts to describe, you know, the wall thickness, right? So pretty easy to do that. We might not need that view, so I'll get rid of it. Mind you, we're doing this all in a MacBook, all in a web browser, no install required. We'll put in a revision table up here in the corner. So we've made a drawing of that. Maybe we need a drawing of the full helmet assembly, right, put together. And actually, let me talk about assemblies just a little bit. You know, you do your design work in this thing called a part studio in Onshape. And then the assemblies, you can take your data from whatever format, Rhino or Onshape native, and then, you know, assemble it with motion and mates, right? So you see the mates that I put in here to make this work. I have something called a revolute mate. And I told it that I can rotate that visor up by 90 degrees. And that was pretty much all the mates I needed for this one. Everything else is set in place, essentially. Designed in place is the only thing moving. Now you can check for interferences. It looks like I might have an interference in here. So I might just double check between these two parts and it will show us if we are indeed interfering. Now, that might be okay in this case because it's a flexible piece of Mylar or whatever this shield is. But if it wasn't flexible, you know, you need to figure out how to adapt the visor or the helmet to fit in. And now I have that information, you know, right here at my fingertips, right? The assembly also provides a place to get your bill of materials set. So I know when I put these screws in, I need a little bit of Loctite adhesive. So I would go in and search my database of items. And then, let's see, there's Loctite right there. And I want to put it on the screws right in here. And I want half of fluid out. We're going to really slather this thing up with Loctite. And that gets added to the bill of materials. Okay. And it's associated with those screws. And if actually, let's do this. This will be a little fun. I'll delete that screw. And I'm going to edit this Loctite just to remove the reference to that screw I deleted. But let's put in another screw, right? I already have this screw here. By the way, you can insert these from the Onshape system. We maintain a library of all of these, you know, types of hardware. It's part of the system. You get it as part of the package, right? And you can put in, you know, different screws, washers, other kind of things. And of course, you can build up your own libraries from other vendors you prefer doing business with. But I'll copy, just Control-C or Command-C if you're on a Mac, paste that just like that. And look what it was smart enough to do. It put in more Loctite when I made the copy, well, not copy, but the second instance of that screw. It knows that we need more Loctite, essentially. And of course, I would need to mate that into place. So I'll show you how Onshape puts parts together. We just have these intelligent mate connector symbols that pop up. We pop it right into the place we want it, rotate it into place. Of course, we would need a hole in that, but you know, it's another story. We'll get into that another time. But just like that, we've added everything. So our parts list is up to date and our drawing of that assembly is up to date with, you know, the bill of materials with the Loctite. It's fixing to go to the next revision. It's already been released at revision A in the past. So what I'm going to do is release this to production. Okay. And I might just need to reassociate this right here. What you're seeing here is the Onshape system. It's doing some smart things to try to, you know, improve performance. You notice the longer it sat there, it created a better, you know, image just automatically. So now what I'm going to do is release this. So in your timeline view, or here, you notice how there's these ECOs in here. And of course, you create an ECO to release something to production, to officially bless it, sign off on it, etc. You can do that in Onshape, just as part of the system, right? So I hit release, and you choose a workflow if you're on the enterprise plan. If you have the professional plan, you get one workflow. That'll work for most situations. So I'll use this one because it's similar to, you know, a standard workflow. Just going to submit something for approval for peer review. We're going to take all these parts, and you can see that you know, we have the drawing, we have the assembly going from Rev A to Rev B. We've made changes. You notice the helmet is still using Rev A. I would prefer to actually set the helmet to be revision B as well. So back in this assembly, I was telling it to use, you know, if I do a report on the helmet, I can see that Rev A of the helmet is used in this top level assembly. And we also have these development versions being used as well. Where used, that's a highly advanced function that PLM and PDM systems have, just part of the Onshape platform. So what I'll do is, and using where used is important, so you can see if this part is you know, if you make a change to this part, do I need to worry about replacing it and updating it in other assemblies, right? So That's a report that we have. But let's go in and update this to the latest workspace version. And you can see now it gives us the higher helmet look here. And this may needed to be redefined, but that's okay. I'll get to that at another point. If I go back to the drawing, it's refreshing itself to update to the new shape, but I could then go in and release it through that workflow. And if you look at the list of things that are being affected by this engineering change order, you can see now the helmet is going to go from Rev A to Rev B. The assembly, of course, is. That's going to go to Rev A. The head, maybe I don't need to rev control my head. There are ways of actually telling it not to do certain things to certain objects. You can actually add other things to this release package. So like those renderings, I'll add that rendering and these renderings, let's say. So it's creating a release package, like a job traveler or a paper-based engineering change notice or order. It's the same kind of concept, right? These are going in at Rev A. I've never released those before. And I want to establish item numbers for all of these. You notice some of them are already here, but let me establish file numbers for the images. And you can see these are just sequential numbers. And then finally, we want to release this whole thing at ECO 2978B based on the 2978 of the top level drawing number here. Submit it for review. Anybody who is an engineer can now go in and mod and sign off on this, whether they're on their phone at the beach or on their Chromebook, helping their kids out with school or whatever it might be. You're gonna be able to have all that information at your fingertips. Now, Mandy is not a member of the engineer team, so I am going to sign in as another person. And if you have questions, start thinking of them now, because I'm going to wrap up the live demo portion here in just a second.
Yeah, don't be shy.
Yeah. And now I'm going to sort on release activities, and you look what's waiting for me right here. Oh, that's not the one. Assign to me, all this first. Oh, you know what? I think it auto-approved it because I used a workflow that lets me auto-approve it based on my administrative capability. So Debbie's not going to sign off on it. I am signing off on it. This will turn to a triangle in just a moment. But I can actually click right into that ECO. And this hyperlink that I'm looking at right here is a hyperlink to that assembly or to that assembly drawing that's released, right? So if I take that hyperlink, and let me just hit the share button. I'll put link sharing on, right? Oh, and let's do this. I'll actually give you a link to the 3D model. And I'm going to put this in the chat, in the chat box. Actually, I'll do organizers, panelists. There we are. No, actually, I'm going to put it in the quest. Yeah, maybe not. Maybe I won't share it right now. Sometimes, you can just, what I'm trying to get at here is you can take these hyperlinks and you can share them really easily, right? That's the point of this, right? Is that you can take a hyperlink, put it in a Google Doc, like the Google Slides that I had. You can put it in your Slack messages, instant messages, whatever it is, and have that instant communication going on, right? So it's pretty cool to see that. Oh, let me, looks like it's working on it. So this would be a good time for any questions. I know a lot of people ask about, how companies use the system and kind of get started with it. Because it's software as a service, it's very easy to get started, right? You simply just buy it from the Novedge website and you have a license for a year, right? It's pretty easy to do it. But think about different ways you can use the system. Like remember the live design review. Even if you don't do any design work in the system, you can import your Rhino data, invite company, do a design review across different companies by that screen sharing mechanism that you saw previously. You can also design an agile workflow for your organization where you're going in and you're creating these different timelines and proposed events that are happening that you can manage and keep track of. You can get your supply chain involved, like sending parts out for quote without having to send file packages out. You're sharing them into the design like a Google Doc. And you can even let them self-service export the document information that they need. So you can go in and give them the export rights instead of them bothering you for, oh, I need step AP214, or I need IGES in this version for my CAM vendor, or whatever it might be, right? So let the user get the file that they need if you want to give them a file. You saw how you have this collaborative workflow where instead of stacking work one at a time, you can stack work on top of each other, and you can reduce the cost and time of your projects. And you can look at different design alternatives. Let me make that window a little bigger so you can see this, but you can look at those branches, you can compare those branches and understand the differences between the different variants of your design. So let's just kind of wrap up while we wait for any other questions to come in. We have, so what you've seen here is Onshape, right? So use the best tool for the job, right? If you prefer using Rhino for your advanced surface development because you like the workflow of how it creates curves and quilted surfaces, use it. But then when you need to go into the mechanical side of things to do advanced design for manufacturability work, draft analysis, prints, assemblies, revision control, that's where the mechanical systems come in, and that's where you can use Onshape, right? And we can import and export the native Rhino format. So it makes it easier than ever for people familiar with Rhino. We saw fearless design communication, sharing information, not lobbing copies all over the place. You saw how you can share with your customers, suppliers, and vendors. There was no software to install for them or for us. And because of all this, you really are going to be shocked at how you can actually perform design projects, right? You can build more innovative products by having a more open, fearless kind of design process without worrying about file management and juggling, which one is the right file, right? Everybody's always on the same page, right? So I would encourage you to take a look into your engineering soul and think about how you could use this technology for the betterment of your customers and suppliers and yourself. There's lots of customers around the world using Onshape. It's in use in schools around the world. There's millions of students running Onshape now. There are thousands and thousands of companies that have completely swapped out from one CAD system to another to Onshape, and there are many that are using it in a complementary fashion, like we proposed today. So, with that said, I'm gonna take another sip of coffee.
Thank you. What a marathon! What a marathon! That was great. You
never know how it's gonna go,
No, you went over all the scenarios, and I love the fact that there's different way to use this combination and collaboration. So it's really custom. There's so many ways you can use it without the design capability alone. It's such a addition to Rhino, and then on top of it, if you wanted, you could use it for flawless design. So it's very exciting because we've never seen Onshape from this angle. So thank you for bringing something new to the conversation. And let me check if there's questions. I don't think there's any question yet. So what I'm going to do, I'm going to take the screen back and show you my screen. I want to thank everybody for attending, and I want to show you the page where you can find Onshape on Novedge. We also, of course, as you know, sell Rhino. And, what an incredible pair. I didn't know many of the things that Mike demonstrated today, so it's really exciting to spread the news, and let's see what this partnership can take us and mostly you. Good luck with your design, and thank you so much again, Mike, for being such a great speaker for Onshape and Rhino today. Have a
Well,
great,
thank you for having me.
yeah, have
Really
a great
appreciate it.
rest of the day, everybody. Bye bye.